Is the combined gas law. Gas law is described by the formula P1 times V1 over T1 is equal to P2 times V2 over T2. These meaning pressure, temperature, and volume. For example, try this problem. Take a moment to write it down. Here are some real-life examples of the combined gas law.
To represent the combined gas law with an experiment, we'll be doing the candle experiment. You will need 5 items: food dye, a candle, a jar, a plate, and matches to light the candle. Essentially, the pan will be filled with water at the bottom, the candle will be placed inside the pan, lit, and then the jar will be placed on top, allowing the water to rise within the jar once the candle goes out. Okay, so we're now going to dye the water green or any color to see the rise in water more clearly throughout the jar. Following that, we're going to light the candle and place it in the tray with the water just below the top of the candle. Now time for the experiment. Essentially what happens is once the jar is placed over the candle, the flame will burn for a second or two and then it will go out. When the flame goes out, the air inside the jar cools down and it creates a lower pressure, even though the air on the outside is still at the regular pressure. The difference between these two pressures allows the water to rise.
The experiment conducted today is the egg in a bottle experiment. Materials needed are a flask or bottle with an opening just below the size of an egg, a shellless hard-boiled egg, a lighter, and paper strips. Step 1. Light a strip of paper with the lighter and let it catch a bit of fire before dropping it into the beaker and placing the egg over the top. The egg should then slowly start to fall into the center of the cup. So, why did this happen? It happened because of the combined gas law. The combined gas law describes the mathematical relationship between the volume, pressure, and temperature of a gas, discovered by the combination of Charlie's law, Boyle's law, and Gay-Lussac's law. In detail, Charlie's law describes if the pressure of an ideal gas remains constant, its volume and temperature are directly proportional. Boyle's law states, if the temperature of an ideal gas remains constant, its pressure and volume are inversely proportional. Gay-Lussac's law explains, if the volume of an ideal gas remains constant, its temperature and pressure are directly proportional. Obviously, the egg doesn't fit due to the larger diameter. The pressure on the inside and on the outside is the same. The only thing applying pressure is gravity, which is not strong enough to push down the egg. When the paper is dropped inside, air molecules start to heat up, which makes them move faster and spread further. As they heat and move, the air pressure rises. Because of the new air pressure inside the bottle, the egg jumps up and down, allowing some air to escape. After the bottle cools, the air pressure inside lowers further than originally because of the escaped air molecules. After letting out the last bit of air molecules, the outside air pressure is now higher than the air pressure inside the bottle, and thus the egg is gently pushed inside the bottle. And with that, that is the science and explanation behind the egg in the bottle experiment.
Hello everybody, today I'll be demonstrating the exploding can experiment. The materials that you will need include a cylindrical can with the aluminum lid cut off so that the can is open on one side. Also, you will need to make a hole near the bottom of the can, as shown here. You will also need a liquid dropper, a tight rubber band, a coffee filter, ethanol, a lighter, and a wooden rod. Step number 1. Cover the mouth or the open part of the cylindrical can with the coffee filter, using a rubber band to secure the coffee filter to the can. Make sure that the coffee filter is not loosely placed on top. That's why you have a tight rubber band. Step number 2. Place 1 full dose of ethanol into the can through the tiny hole that you made earlier using the liquid dropper. Then, you will want to shake the can to be sure that the ethanol gets to all parts inside of the can. so that the inside is mostly coated with ethanol. Then, grab the wooden rod and use the lighter to create a flame on one end of the rod. For step number 5, you'll want to place the rod containing the flame through the tiny hole that you created at the bottom and watch for the explosion. Here's an important note. Make sure that after the ethanol is placed into the can, you immediately light the fire on the rod and place it through the tiny hole at the bottom. This is because ethanol evaporates quickly, and so the longer you wait to place the fire through the hole, the less likely the experiment may work. If this happens to you, place more ethanol into the can and quickly light the fire. If you did this correctly, the coffee filter should fly up into the air once the flame enters the inside of the can. This is because of the combined gas law. As temperature increases, because of the flame that enters the inside of the can, the gas particles inside of the can begin to move faster and collide more frequently with greater force. The pressure inside of the can will remain constant because the volume of the gas will increase due to the rapid movement and expansion of the heated gas particles inside of the can. Therefore, the coffee filter flies up into the air due to the increased volume of the gas inside of the can, which can no longer contain itself within a closed space.
And here's the answer to the problem I offered you earlier.